S.Jayapriya, working as Assistant Professor in the Department of Chemistry, St. Joseph College, Tirupur. Now we are going to discuss about classification of polymers. I discussed this topic under three headings. Firstly, we see the introduction to the polymers. Secondly, polymerization and classification of polymers. Finally, in detail about unique features of polymers. We use polymers in various applications. They exist in both natural and synthetic. So we discuss what are polymers and why polymers are so common. Let us see the introduction. In a very simple term, we can say the polymers are high molecular weight, large single molecule. We otherwise known as macromolecules. It consists of many repeating structural units. The term polymers derived from Greek words. Poly means many and mers means parts or units. Based on this, we can define polymers are macromolecules formed by the repeated linking of large number of small molecules called monomers. Now we know that polymers are made up of monomers. What is monomer? Monomer is a micromolecule which combines each other to form a large single molecule called polymers. For example, ethylene monomer are polymerized to form polyethylene. When ethylene monomers polymerize, the weak pi bonds in ethylene are destroyed and a long chain of CH2 units are produced. Next we are going to discuss polymerization. Polymerization is the process in which a large number of small molecules combine to give a macromolecules with or without elimination of simple molecules like water, HCl, sulfur dioxide, carbon dioxide, etc. Based on the synthesis, polymerization can be classified into three types. First one is addition polymerization, condensation polymerization and copolymerization. Addition or chain growth polymerization. In this process, the polymer formed is an exact multiple of the original monomeric molecule and the monomer should contain one or more double bonds. Polymerization can be carried out by using heat, light, pressure or a catalyst. No byproducts, that is, without elimination of any simple molecule during this reaction. Example, polyethylene, polypropylene, polystyrene and polyvinyl chloride, etc. The next one is condensation or step growth polymerization. The polymerization proceeds by stepwise reaction between the reactive functional groups followed by the elimination of small molecules like water, HCl, SO2, carbon dioxide, etc. Example, hexamethylene diamine react with adipic acid. It gives polyhexamethylene adipate or nylon 6,6. Bakelite, polyester are also prepared by this method. In copolymerization process, two or more monomers combine to form a high molecular weight polymers. Many commercially important polymers are copolymers. Example, styrene butadiene rubber. Let us see the classification of polymers. Several parameters are used to classify the polymers. Here we are discuss three parameters based on the origin, based on the monomer, based on the structure. Polymers are classified into natural and synthetic polymer based on their source. Polymers obtained from the natural source are called natural polymers. Examples, starch, cellulose, proteins, nucleic acids, natural rubber, etc. Synthetic polymer is a man-made macromolecules. These polymers are synthesized in laboratory to replace natural polymers. Synthetic polymers are stronger, durable, cheaper and more versatile than the natural polymers. Example, polyethylene, polyvinyl chloride, polymethyl methacrylate, nylon, etc. Based on their backbone of natural and synthetic polymers, further it can be divided into two types. organic and inorganic polymers. In organic polymers, the backbone consisting of only carbon atoms. Example, polyethylene, polyvinyl alcohol and polyvinyl chloride. In inorganic polymers, the backbone consists of atoms other than carbon. Example, polysilicates, silicones, polyphosphoric acid. Polymers are also classified on the basis of types of monomers. Similar monomers combined forming homopolymers. Example, polystyrene, polyethylene, etc. Homopolymers are further classified into three types based on their chain configuration, that is, linear, branched and cross-linked polymers. When different monomers combine forming copolymer or heteropolymers. Example, polystyrene cobutadiene. Based on their structure, we can classify the polymers into four types. First one is random polymers. In this type of copolymers, there is no regular arrangement of monomers. Here we can see two different monomers A and B. When the polymer is formed, there is no regular pattern in the arrangement of monomer units. Therefore, it is a random polymers. Second one is alternate copolymer. In this, monomer units are alternatively arranged. A monomer units having different functional groups upon undergoing condensation reaction yield alternate copolymers. In this alternate polymer, both monomer units A and B are alternatively arranged and this can be visualized. The third one is block copolymer. In this type of copolymer, monomer present in the form of blocks. This means the copolymer which is formed by the combination of two different monomers unit in the block copolymer. The final one is graft copolymer. In this type, there will be polymeric chain formed by one monomer, while the branch are constituted by other monomer. It is called graft copolymer because we can observe branches in it. So, now we are going to discuss about properties of polymers. Polymers can many unique properties than other materials like metals, ceramics, etc. Let us see some properties of polymers. The important property, it is very light in weight, excellent strength, flexibility, corrosion resistance, excellent durability. Due to this behavior, we are using polymers in many ways like fibers, monofilaments, textiles, rope, film, foams, moldings, fillers, additives and many other applications. Thank you for watching.